marvel at IBM's Selectric typewriter. I still recall clearly the day my parents brought one home. I thought at the time, that's a magnificent machine, and you know, I still do. It paved the way for computer printers because the Selectric had an early version of a digital to analog converter. Let me show you. The converter controls this ball. It distinguished the Selectric from all their typewriters. Instead of an individual lever for each letter, they're all gathered on the type element. Lowercase on one hemisphere, uppercase on the other. Now, to type a letter takes only a fraction of a second, but if slowed down, we can see the motion of the type element. The letter G, for example, is located on the lower left-hand side of the type element. To access that letter, the type element needs to rotate and then tilt and strike. Now, let's look at the very clever mechanism that controls the motion of this ball. There are two cables that are kind of buried in here, a little hard to see, but they control the tilt and rotation of the ball. Pull on the top one, and it tilts to one of 4 rows, and pull on the bottom one, and it will make it rotate to one of 22 columns. An amazing mechanical digital to analog converter controls these cables. It's buried in the typewriter. I can just barely see the top of it down here. But it's a set of arms designed to give the cables precise tugs. It's based on an old device called a wiffle tree. It's a contraption that distributes force evenly through a set of rigid linkages. Here, the typewriter keys pull on the colored tabs, which the wiffle tree translates into a precise rotation of these pieces, which in turn tug on the 2 cables I showed earlier. The yellow tabs control the tilt, the blue ones the rotation. Let's look at only the tilt mechanism. It requires 2 bits of information to access the 4 rows on the ball, the home position plus 3 tilt positions. The characters Z, T, half, and J make up the front row on the ball. No rotation is needed, only tilt. The letter Z requires no tilt and is represented by the bits 0, 0. The type element simply needs to move forward and strike. Yank on this tab and you pull the tilt cable 6/100ths of an inch. This happens in 7 milliseconds and gives 1 unit of tilt to select the letter T. Pull on this tab and the cable is yanked 12/100ths, twice the distance, and you get 2 units of tilt for the character half. And lastly, pull on both tabs and you get 3 units of tilt to access the bottom row and type the letter J. The rotation works the same, but more complex because there are 22 positions. The importance of all this is that the discrete motions of the keys are converted to an analog movement of the ball, which means that it's possible to hook a computer to a Selectric and use it as an output device. It wasn't easy, but it started the word processing revolution.